Today we're going to multiply, multiply. So the best way, I think, for us to learn it is just to talk through, and I'll do a few examples and we'll try to figure out exactly what multiply means. I know we've done this in the classroom before, but here's an example. 2 times 3. And you know what 2 plus 3 is. 2 plus 3 equals 5. And we can also draw that with dots as well. Here, let's call them 2 little cherries here. And we can also have 3 blueberries. How many fruits do we have altogether? We can add, 2 cherries and 3 blueberries, so we have 5 pieces of fruit in total. And we can also show that on a number line as well. I'll quickly click on that one here. And draw some arrows. So zeros there, so we're like looking at a ruler here. 0, 1, 2, 3, 4, 5. And if you're sitting 2 to the right of 0, because we have 2 cherries already, and we add on the 3 blueberries, we can count 3 to the right. So we count across to the 5, so we can just move over and jump across to 3, 4, and then to the 5, and we end up with 5 pieces of fruit. So that's our addition. We're adding the 2 fruits together with the 3 to get 5. Now, multiplication, the easy way to think about that and timesing something is just a simple way of doing addition over and over again. That's why we've been doing it up on the board for weeks, practicing our skip counting in the columns. So we're not going to add 2 and 3. We're going to multiply them. We're going to add 2 to itself 3 times. So we're going to go 2 plus 2 plus 2. We didn't do anything with the 3. Well, how many 2's do we have there? We have 1 2, 2 2's, and 3 2's. And we're counting them the same way I counted the blueberries. 2, 3 2's. We got the 3 tells us how many 2's. So what's 2 times 3? 2. And I add on 2 and again, and 2 and again. So 2 plus 2 is 4, plus 2 equals 6. Now that's only one way to think about it. The other way you could think about it is we could have said, instead of having 2 added to itself 3 times, we could have added 3 to itself 2 times. And this could be a little bit confusing at first. But you can switch them around in multiplication and it won't matter. So 2 times 3 can also be written as 3 plus 3. Where's the 2 gone, you're probably wondering? Well, it just means the multiplication will just mean 2 lots of 3. But here we go, I'm looking at the cherries and blueberries. I'm adding them together, 2 and the 3, and that gets 5 there. But we've got 2 times 3 is the same as 3 plus 3. 2 in this case is how many lots of 3 we have and how many times we're going to add 3 to itself. So what's kind of interesting is no matter which way you switch those 2's and the 3 around here, 2 plus 2 plus 2 equals 6. We can also do 3 added to itself 2 times. 3 plus 3 equals 6. And we get the same answer. So this is probably the first time you see it. And like with multiplication, no matter what path you take, you always get the same answer. So if you switch them up, even though they are different things, you'll still get the same answer. 6 there, 3 plus 3, 6. Now you're probably thinking, well, where does this multiplication mean? Or where is it even useful? And we use it to simplify counting. Otherwise, it's going to take ages to count, like 2 plus 2 plus 2 plus 2 plus 2. But let's just do an example, though. Let's stick with the fruit. And let's say we've got lemons. We've got a bunch of lemons over here. And we'll do them in rows of 3. 1, 2, 3 lemons. 1, 2, 3, 4, 5, 6. Oh, I don't mean to count them. Now think about how many you have there. Now if I said, how many do we have there? How many lemons? You could just count them one by one. Not too long. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lemons. I just gave you the answer, but 12 lemons. But there's an easier way and faster way than counting a 1, 1, 1, 1, 1, 1, 1. Like, let's put them into rows. How many lemons do we have in each row? From side to side, left to right. How many lemons do we have in each row? We've got one row there at the top. Here it is. I'm going to group it off. How many lemons in a row? We've got 3 in a row. Now let me ask you another question. How many rows are there? If you group the lemons into 3s, how many rows would we have? We had one row at the top. Here's the second row. Here's the third row. And this is our 4th row here. An easy way to count it is you could say, I have 3 lemons per row, and I have 4 rows. So 3 lemons per row and 4 rows, 4 times 3. So 4 lots of 3, 4 times 3 lemons. And that should be equal to 12. And just to make it just gel a little bit more with what we did there with the addition, 4 times 3, if you say it out, say 4 times 3, I usually visualize 3 being added together 4 times because we have 4 rows. 3 plus 3 is 6, plus 3 is 9, plus 3 more is 12. And if we go, let's go back down here. If we learn the same multiplication could also be interpreted or thought of as 3 times 4 because that's the same as well. We can switch the 3 and the 4 around here. And it's just one of the cool properties. 4 3 times we can do now. Let's do 4 3 times. 4 plus 4, 4 plus 4 plus 4, 8. And let's add on 8 plus 4 is 12. And, in Australia we always say 4 times 3. But I like to say lots of or groups of. I think sometimes you even hear people say like, I've got 4 3s. And that kind of might make sense with you as well, the way they think about it. 4 3s. What's 4 3s? And then what they're meaning is 4 times 3. What are 4 3s? So if I say to you, what's 4 3s? We got 1 3, 2 3, 3 3s, 4 3s. What are 4 3s? When we add them up, it's 12. So we could also say, what are 3 4s? And we'd say, let's put it down here. That is, let's write it with words. That is 4 3s. And it is that literally. It is 4 3s. Write down 4 3s and add them up. That's what that is. And that's what you'd have there. 4 times 3. 3 4 times. This is here. This one is 3 4s. And, we could also write that as 3 times 4. And they all equal 12. And you're probably thinking, right, this looks kind of cool. It's a nice little trick. But it was quicker to count all these. You're thinking, doing all that maths there, that was hard work. Didn't have to do that. But when you get to bigger numbers, and this will happen a lot as you get older or you do harder maths, you don't have time to draw these dots. There could be 100 in your row. And each row could have 100 lemons in it. It would take you forever. So that's where multiplication comes really useful. Knowing how to multiply bigger numbers. Now, one thing that this is a trick. And my brother did this to show something to me, to show how much he was smarter than me. And, he'd say to me, what is 3 times 1? And, I'd look at it and I'd think 3 plus 1 in my brain. And I'd say 3 plus 1 equals 4. And 3 times 1, that must be 4 as well. And then my brother would be like, nah, you don't. It's 3. And I'm like, how could that be? How could 3 times 1 be 3? And I just don't think I understood it. But, the way you can view that is 3 ones. And 3 ones is this. 1 plus 1 plus 1 equals to 3. Or you could view it as 3 1 times. 1 lot of 3. And that's just 3. 1, 3. Because we're not adding anything else to it. 1, 3. That's just 1, 3 right there. That's why 1 times anything is always going to be that number. So 100 times 1 is going to be 100. But yeah, 100 times 1 equals 100. And I could even say 1 times 39 equals 39. And I could also, so that's kind of interesting. There's one other really cool trick about multiplication, and that's when you multiply by 0. Now, let's give you an example. So 3 plus 0 equals 3. Because you're adding nothing to your 3. You have 3 there, and you're adding no more onto it. You've got 3 lemons, plus 0 lemons is 3 lemons. So that's just 3. So what is 4 times 0? Well, this is saying to us 0 4 times. 0 4 times. 0 plus 0 plus 0 plus 0 equals 0. Because nothing plus nothing plus nothing equals nothing. And another way to think of it is 4 0 times. Well, we don't write anything because we're not going to write down the 4. If I write down a 4 there, then I think. So that's saying to us, it's got to be 0. That is 4 zeros. We can write it in words. And we write down 0 4s. We'll just write a big blank right there. That's my 0 4s right there. I've drawn it. Big blank, 0 4s. So anything times 0 is 0. Doesn't matter how big your number is. If it was 5,493,692 times 0, your answer is going to be 0. What's that number times 1? 0 times 17. That is 0. I think that's enough. I might just leave it there. All right. Good day, everybody.